third part of lecture 8, that is bacterial growth, and in the second part we learn about the bacterial growth curve, that is different phases, lag phase, log phase, stationary phase and death phase of bacterial growth. And we have also learned, their significance. That means how we can use the bacterial growth, different bacterial growth phases to produce our desired products. But that's not all. Okay, so bacterial growth curve is actually very important in terms of not only in the industry but also in terms of their pathogenesis. How the bacteria they cause disease, and also in terms of doing research. Okay, so for example, one important use of bacterial growth curve is to study of genetics and metabolism of bacteria. That means, okay, I'm just telling bacteria, but it's not actually like this. So think about microbes. So not only bacteria, other microbes such as yeast, they also follow the same growth pattern. Okay, so we can use, not only in the industry, we can also use the bacterial growth curve to study the genetics and metabolism of bacteria. Okay, so how we can do that? One approach is to study the synchronous growth. Okay, so first let's try to understand what is synchronous growth. So synchronous growth means a situation in a cell culture when all the cells divide at the same time. Okay, so now think think about a normal scenario. Say you are culturing bacteria in the media. Okay, so all the cells of in that culture will not divide at the same time, right? This is natural, this is normal, that when we culture cell in culture media, all the cells all the cells they don't divide at the same time. So some cells are dividing now, some cells will divide after a few times, few minutes or few hours. Okay, so but in case of synchronous growth, all the cells will divide at the same time. Okay, so now if we can apply the synchronous growth in the cell culture, that means all the cell will divide at the same time, then we can study the genetics and also the metabolism. Okay, but how, but it will not occur naturally. That means all the cells of a culture will not be in synchronous growth naturally. Okay, but we can achieve it. Okay, actually there are some chemicals, okay, which are called cytostatic agent. So if we add the cytostatic agent in a cell culture, the growth or cell division of all the cells will stop. Okay, then when you will remove the cytostatic agent, the cells will start dividing at once at the same times. Okay, so by this way we can achieve the synchronous growth in a cell culture. That means if you want to study the genetics or metabolism of your target bacteria, okay, and you want to use the synchronous growth, then what you can do, culture your bacteria in the culture media and then add cytostatic agent. The growth of the all the cells will be stopped. Okay, and they will come in the same state, then remove the cytostatic agent, then all the cells will start multiplying or to divide at the same time. Okay, so by this approach we can achieve synchronous growth and study metabolism or genetics. Okay, now we we learned about bacterial growth. So can we control the bacterial growth? Definitely we can do that. Actually, control of bacterial growth means we can decrease the number of bacterial growth. Even we can actually kill all the bacteria. Okay, so that means control of bacterial growth means to reduce, actually most of the time it means to reduce the growth rate of bacteria. Okay, and we can do this by different methods. There are some physical methods like heat, pasteurization, filtration, osmotic pressure, radiation. There are also some chemical methods. Okay, by using both physical methods and chemical methods we can reduce the rate of bacterial growth. That means we can reduce the number of bacterial cells. Okay, and these things, I mean, reduction of number of bacterial cells, actually we can also express them mathematically, and we can call them rate of death. Okay, so the rate of death means the the decrease in the numbers of bacterial cells in certain time. Okay, so now the rate of death. Okay, so I mean, say for example you want to use a physical method or chemical method to kill bacteria. Okay, and these things, okay, that means the rate of death will depend on several factors. So what are those factors? The number of microbes, the number of microbes present there, environmental influence, I mean what's the temperature, what's the pH, okay, time of exposure, and microbial characteristics. So these are the factors which will affect the rate of bacterial death. Let me say, for example, you want to use heat to reduce the number of bacteria, or you want to heat to kill bacteria. So all the bacteria, they will not die in same manner, in same pattern. Okay, some bacteria, they are more resistant to heat, so they will die slowly. Okay, or say for example you are using heat, but in one area you have you heat it for like 30 minutes, in another area you heat it for 1 hour, the effect will not be same. Okay, so time of exposure, what kind of microbial characteristic, that means what kind of microbes are present there. Okay, so and what was the initial number of microbes. So if there are more numbers of microbes there, you have to expose you for more longer time. If there are few number of microbes, maybe you don't need to expose for very long time. Okay, so these all factors will affect the rate of the death rate of bacteria. Okay, now, when you will use chemical method to control the bacterial growth or kill the bacteria, there are several factors that affects the efficiency of the chemicals that you use. Okay, so what are the factors affecting efficiency of chemicals? Concentration of agent means concentration of the chemicals that you are using, initial load of microbes, that how many microbes are present there, environmental factors such as temperature, pH, salt concentration, etc., presence of organic matter. I mean, if uh, some organic matters are there, okay, including the microbes, the efficiency of chemicals will be different. Usually more organic matter, the less efficient the chemical will be. Okay, then time of exposure. Okay, I mean, you may treat, I mean, expose the microbes towards your chemical for 10 minutes or 1 hour. The result will be different. Nature of organism. Some microbes are more resistant. So, for example, you know the name of the disease, tuberculosis, jock, right? And tuberculosis is caused by a bacteria which are called mycoplasma. The mycoplasma bacteria are very resistant. Okay, so if you want to use chemical to kill mycoplasma, actually, I mean, exposure time, you have to expose for longer time. Okay, okay, so now, I mean, we learned that there are physical method and chemical method to control the bacterial growth. Now we'll try to learn in more details about the physical method and chemical method. First, physical method, and there are different physical method like heat. Okay, so and we can use heat differently to kill bacteria. We can use dry heat. Dry heat means no moisture will be there. Okay, and the dry heat conditions are like 170 to 180 degrees Celsius for 1 hour. This is the basic parameters of dry heat. I mean, if you want to kill bacteria by using dry heat, you have to heat at 170 to 180 degrees Celsius for 1 hour. And why the cells die at this temperature? Because denaturations of cells occur. Okay, this was one method of heating heat. Okay, so you can also use heat in a different way, like moist heat. Okay, in case of moist heat, there will be heat also plus vapor, moist. Okay, moist come from water. So in case of moist heat, the effect on the bacterial growth will be, will be exerted from both heat and also the vapor pressure. Okay, the vapor generated from the moist. Okay, and usually this method, moist heat, is more efficient than dry heat. So why I'm saying that? Because say for example, if you want to kill bacteria by dry heat, you have to use 170 to 180 degrees Celsius. But if you want to use moist heat, 121 degrees Celsius will be kind of enough. So if we just can heat the cell for 121 degrees Celsius at 15 psi pressure for 10 to 15 minutes, okay, it will be enough to kill all the bacteria, and not only bacteria, all the spores. Okay, so while in dry heat you have to use this high amount of temperature, 180 degrees Celsius, very high, for 1 hour. But if you use moist heat, just use 121 degrees Celsius for 10 to 15 minutes. Okay, so that will be enough to kill all the bacteria and spores. Okay, so well, actually this condition we frequently use in the laboratory. Okay, so you will see when you will be in the laboratory. So in the laboratory we have to frequently sterile many things, like we have to sterile the media, culture media, we have to sterile many utensils or equipments that we use to do the study. Okay, and to sterile those equipments and media, we use this condition: 121 degrees Celsius, 15 psi for 10 to 15 minutes. And this is called autoclaving. Okay, so actually there are machines in the laboratory which we call autoclave machines. Okay, so we use the autoclave machines to sterile our like media, utensils, or equipments. Okay, okay, so this was about heat. There are other physical methods, say radiation. Okay, so radiation can be ionizing or non-ionizing. And ionizing radiations are like, for example, X-rays, gamma rays, electron beams, and they kill the bacteria by destroying the DNA. Okay, now non-ionizing radiation. So, for example, UV. Okay, and most effective wavelength is around 260 nanometer. Okay, well, there are also other physical methods. So for example, filtration. Okay, so in case of filtration, we passage the liquid through a filter. Okay, and the pore size of the filters are usually very smaller, like 0.2 millimeter or less. Okay, and there are also some specialized filters which we use in sophisticated machineries when we need very when we need to sterile, like for example, especially in the industry or in the laboratory, if we want to sterile the air. Okay, so at that time you have to use very sophisticated filters, and HEPA filters is an example of that kind of very sophisticated filters. Okay, well, not only this, there are other physical methods such as uh, osmotic pressure. Okay, we actually can use osmotic pressure to kill bacteria. So how we can create osmotic pressure? So you just have to put the cells in different solute concentration. Okay, so you know what osmotic pressure is, right? If we put a cell, if we put something, suppose for example the cells. Okay, inside the cells there are certain concentration of solutes. So if you put the cells in a solution where the concentration is different, so we know difference in concentration, it creates osmotic pressure. Okay, and so if we put a cells in a different in a solution where the concentration is different, it can cause a osmotic pressure, and this osmotic pressure can cause the lysis or destruction or death of the cell. Okay, anyway, this was about the physical method of controlling bacterial growth or killing bacteria. Now let's talk about the chemical methods. So there are different chemicals. So for example, halogens like chlorine gas, bromine, iodine solution, alcohol, various antiseptics, chemicals, antibiotics. Okay, these are all chemicals, and we can use these chemicals to kill bacteria. That means control the growth of bacteria. Okay, and we already know that there are several factors which affect the efficiency of the chemicals. Okay, well, now as I said, I mean, says for example, you want to use a certain chemical to kill bacteria. Okay, so you actually have to first identify what kind of bacteria you want to kill, because different bacteria has different level of resistance. Some are very resistant, some are less resistant. So if you want to kill very resistant bacteria, you have to use a high efficient method. Okay, both high efficient method to kill it. Okay, so if you want to kill a less resistant bacteria or microbes, you have to use less efficient, I mean, if you can use less efficient methods. Okay, so this list, okay, this list, it shows the I mean, it actually lists the microbes based on their resistance. So for example, in top the most resistance one, and in the bottom the less resistance ones. So based on, according to this list, endospores, that means spores of bacteria, they are most resistant. Then come mycobacteria. Okay, then cyst of protozoa, vegetative protozoa, gram negative bacteria, fungi, virus without envelopes, gram positive bacteria, virus with lipid envelopes. Okay, okay, so uh, that was all about lecture 8. Uh, I'll suggest and request you that this lecture, I mean, bacterial growth is very important. If you want to understand bacteria, not only bacteria, if you want to understand microbes, you need to understand their growth. Okay, it's very important. So please study this chapter very sincerely and attentively. Okay, so thank you for your patience. Well, actually, I just sorry, I have missed one thing. The last thing that I wanted to talk with you, which is microbial preservation. Okay, so we learned about bacterial cell, but we also should, I mean, we learn how to control the bacterial growth by physical or chemical method. Actually, we can also preserve the bacterial growth. Okay, preserve means, I mean, we will not kill the bacteria. Rather, we'll preserve them in a way that they will be alive but not multiply. Okay, so that means the microbial preservation means maintaining cells in a viable condition without growth. I mean, during preservation, the cell will not grow. That means the cell will not multiply, but they will be viable. Okay, they will not be dead, they will be viable. Okay, so how we can preserve the bacteria? Well, actually, there are different methods by which we can preserve bacteria, but the most frequent method is to use cold temperature. Okay, so if we keep the bacteria at cold temperature, usually their cell growth stop. I mean, okay, they cannot multiply at cold temperature, but what, how much cold we'll use? It actually depends. So, for example, if you want to preserve the microbes or bacteria for short time, okay, in that case you can use 4 degrees Celsius. Okay, so if you store your microbial culture or bacterial culture at 4 degrees Celsius, they will not multiply. Well, the reality is at 4 degrees Celsius the cells actually can multiply, but the rate is very slow. Okay, so that's why we can store microbes at 4 degrees Celsius, but not for very long time. Okay, so we will store or preserve microbes at 4 degrees Celsius only if we want to store them for short time. That's why in the refrigerator, okay, even if we keep our food in the refrigerator, they get rotten, because at 4 degrees Celsius The growth of microbes, they get very slow but not completely stopped. So that's why at 4 degrees Celsius we can store our food for a certain period of time, but not for a very long time. So what we do if we want to preserve our food for long time, we actually keep them in the freezer, right? Which is around -80 to -20 degrees Celsius. Okay. Well, now one thing is, if you keep your bacteria at -20 degrees Celsius, there is a high chance that your bacterial cell will die. Okay. So now if you want to preserve your bacteria, that means you want to keep them alive. Okay. But the growth will be zero. The growth rate will be zero. In that case, you have to use much colder temperature. Okay. And usually in the laboratory or in the industry, we preserve them either at -80 degrees Celsius, or we can use liquid nitrogen. Liquid nitrogen is extremely cold. Okay, the temperature of liquid nitrogen is around -195 degrees Celsius. Okay, so in the laboratory or and at this temperature, I mean at -80 degrees Celsius or minus liquid nitrogen temperature. Okay, if we store the bacteria at this temperature for long time, we can store them. Okay, for long time. Okay, for several years. Well, okay. However, if you want to preserve or store microbes at -80 degrees Celsius or minus or at liquid nitrogen temperature, okay, which is extremely cold, you have to use a special chemical. So those chemicals are called cryopreservative chemical. Okay, so if you want to preserve your bacteria at -80 degrees Celsius or more cold temperature, you have to add cryopreservative there with them. And also you have to use a special tube or vial to store. I mean, you just cannot keep normal plastic or normal gas vial at that temperature. Okay, they will actually get burst out. Okay, so if you want to preserve something as preserve something at very extreme cold like -80 or -190 or 95 degrees Celsius, at that time, not only you have to use a special cryopreservative chemical, also you have to use a special cryo vials. Okay. Well, that's all. Thank you. Thank you for your patience.